In this video, we're going to look at 3 more examples of U substitution, how to find antiderivatives using U substitution. So example A is to evaluate the integral or find the antiderivative of x times square root of x plus 1. In example B, we want to find the antiderivative of x to the 5th times square root of x cubed plus 1. And in example C, we want to find the antiderivative of x over x to the 4th plus 1. So let's begin with part A. To find this antiderivative, if we want to use U substitution, we want to let U capture what's inside the parentheses or denominator, or inside a radical like here, which is x plus 1. From there, we can solve for x. It's U minus 1, and differential du is equal to differential dx. Look how this integral now is transformed to an integral in variable u. X is u minus 1, and then x plus 1 is u. So we have square root of u, and dx is du. It is completely transformed. So this is u minus 1 times u to the 1/2 times du, which is equal to u to the 3/2 power minus u to the 1/2 power du. These are 2 basic antiderivatives which are done with a power rule. So the antiderivative of u to the 3/2 is u to the 5/2 over 5/2, and the antiderivative of u to the 1/2 is u to the 3/2 over 3/2. We can add a c here. All we have to do is express the answer in variable x. This is 2/5 u to the 5/2 minus 2/3 u to the 3/2 plus c, and recall that u is x plus 1. So 2/5 x plus 1 to the 5/2 minus 2/3 x plus 1 to the 3/2 plus c. For part B, we want to evaluate the integral of x to the 5th times square root of x to the 3rd plus 1. And before we do that, let's rewrite it as follows, using the exponential notation, x cubed plus 1 to the 1/2, and let's write x to the 5th as x cubed times x squared dx. You'll see why in just a minute. Once again, we're going to let u be what's in parentheses, which is x cubed plus 1. From there, we solve for x cubed in terms of u. It's easy to do. It's u minus 1. Du is 3x squared dx, or 1/3 du equals to x squared dx. So if we go to the integral and start transforming into variable u, x cubed plus 1 is u. It's raised to the 1/2 power. As you can see, x cubed is u minus 1, and x squared dx is 1/3 times du. So this is 1/3 times u to the 3/2 minus u to the 1/2, which are 2 basic antiderivatives using the power rule. And now we can find those antiderivatives in variable u. It's 1/3 u to the 5/2 over 5/2 minus u to the 3/2 over 3/2. We can add a c now or wait till we get back to x. 1/3 times 2/5 u to the 5/2 minus 2/3 u to the 3/2. We can now add a c. And now let's send in 1/3 and replace u with x cubed plus 1. So this is 2/15 x cubed plus 1 to the 5/2 power minus 2 over 9 x cubed plus 1 to the 3/2 power plus c. Now let's solve part C. Part C is equal to it's the antiderivative of x divided by x to the 4th plus 1. Now it seems like we should let u be x to the 4th, but that is not right. To solve this, the power 4 is too big for power x to the first power, so we want to rewrite x to the 4th as x squared squared plus 1. This is the key. In this example, we do not want u to be the entire denominator. We want u to be x squared. If u is x squared, du is 2x dx. 1/2 du is x dx. And so we go back to the integral and transform it to an integral in variable u. X dx is 1/2 du. X squared is u, but then it's squared, so it's u squared plus 1 in the denominator. So it's 1/2 times antiderivative of 1 over u squared plus 1 du. We know that that is a basic antiderivative. It is arctan of u, inverse tangent of u, plus c. And as a last step, we want to write the answer in variable x. So the answer is the integral of x over x to the 4th plus 1 dx is 1/2 arctan of x squared and plus c.